Okay, so now we're going to go back and finish up talking about trig functions. This is where your trig solving skills are going to come in super handy. First of all, I need to make sure that I can find critical numbers. So since I have sine and cosine, I know those functions are always continuous. So I shouldn't have a problem there like I did with the rationals. So I need to go ahead and find that derivative. Okay. So f prime of x should equal derivative of sine is cosine minus derivative of cosine is a negative sign, but it's already a negative radical 3 cosine, so negative negative actually makes that positive. And now I have a sine of x. Okay, so notice that, I forgot to say this earlier, we're only working with the interval from 0 to 2 pi. So any critical numbers need to be found in that interval, because technically these graphs will keep oscillating for an ever and ever, so they have infinitely many critical points, or critical numbers. So that's why I need to kind of narrow it down. All right, so I'm trying to figure out where this derivative will equal 0. So I want 0 to equal cosine of x plus radical 3 sine of x. So that means I want negative, cosine of x to equal radical 3 sine of x. Okay, so I have sine and cosine. Ideally, this would just be either sine or either cosine. But I don't have that luxury. So I'm going to dig into my bag of tricks when it comes to trig. And I'm going to, I'm going to divide everything by cosine. So this will now get me to negative 1 is equal to radical 3 radical 3 sine of x divided by cosine of x, aka I will have negative 1 over radical 3 is equal to sine of x over cosine of x. So that must mean that I'm looking at wherever tangent would equal a negative 1 divided by that. So using my trusty old unit circle, I can actually not think about it as tangent. I'm actually going to go back and think about it as sine over cosine. So as long as I know that it's sine over cosine, I can actually use that to find the angles, and here's how I'm going to do it. If I divide both of these values by 2, that's still equivalent to what I had. So if I think about the fact that I have a 1/2 for a sine value and a radical 3 over 2 for a cosine value, I can use that to state that sine would equal a half when x is equal to pi over 6. So I know I'm looking at either pi over 6, 5 pi over 6, 7 pi over 6, or 11 pi over 6. Because I was able to identify the reference angle. And if you already have your tangents memorized, rationalize the green stuff and figure out what that would be. However, since I have this right here, I'm going to go ahead and now think about it as tangent. So I want a negative 1 over radical 3 to equal a tangent value. And I know tangent is negative in the second and fourth quadrant. So that must mean that my answers, my critical numbers, are going to be these two right here. Okay, so that makes stuff pretty easy for me. If you have questions about the trig, feel free to ask. More than happy to help you with it because that's what I'm doing with my pre-calc right now. So I need to make my number in the line, and I need to look at my first derivative. Oop, can't erase that part. So here we go. I need to test out my 4 intervals that I have. So I'm going to pick, since sine and cosine, I'm going to be strategic with my choices. I'd rather use zeros and ones if possible. So as a result, I'm going to use pi over 2. So f prime of pi over 2 all right, cosine of pi over 2, so I'm talking about the x value, so that's 0, plus radical 3 times a 1, so that's going to be a positive number, right? And I want to use another instance where I have a 1 or a 0, so I'm going to go ahead and use, I'm going to use pi. So replace this, instead of pi over 2, change it up to a pi. So f prime of pi, cosine of pi is a negative 1, plus square root of 3 times sine of pi is 0. That's going to be negative. There we go. Now I need to use a value greater than 11 pi over 6. So I'm going to go ahead and use 2 pi. Even though it's the boundary, like I'm not going to include it, but it's a nice value that's there that will allow me to get what I need. So if I change from that and actually go ahead and plug it into my derivative, so f prime of 2 pi, cosine of pi is 1, cosine of 2 pi is 1, sine of 2 pi is 0, so I get a positive number here. Okay, so there we have it. Now I have to, again, take into account the interval that I was working with. So here's what I'll say. From 0 all the way to 5 pi over 6, or from 11 pi over 6 to 2 pi, f of x is increasing. All right. If I look at it from 5 pi over 6 to 11 pi over 6, f of x is decreasing. All right. So we're going to go ahead and state that, or find f of 5 pi over 6. So a little jump cut. And here we go. I evaluated f of 5 pi over 6, and you have some of my work there, so you can see how I did it. So because at 5 pi over 6, I went from positive to negative, I can go ahead and state that this would have to be a relative maximum. It keeps increasing, then it maxes out, then it starts to come back down. And if I look at 11 pi over 6, it's negative. Then it turns into positive, so it bottoms out. So I'm going to say this is a relative minimum. And that's all you have to do with these trig ones. Again, it comes down to how comfortable you are solving trig equations.